Let us begin. If we are going to add or subtract radicals, it is very similar to adding and subtracting variables. So similar that I would say that it is exactly the same. If I gave you two variables, 3x plus 2y, can you tell me that answer? Yes or no? He waited patiently. Tavleen! Oh, certainly. If I gave you this expression with two variables that are added together, could you tell me the answer? Of course you can't. And why is that? Because they are not, what is the math term for it? Stanley? They are not like terms. You cannot add them together because you do not know what x is and you do not know what y is. So can you possibly tell me how much you have at the end? No, of course not. Could you do this? This is no. Could you do 3x plus 4x? Yes, what would that be? Pardon me? 7x. Well done. Could you do this? 3x squared plus 2x. No, of course you can't. Why? Because they're not like terms. Why are they not like terms, Sonia? One's a squared and one's an x. Those aren't the same things, are they? X squared is way bigger than x. So this is no. But could you do this? And what would that be? 5x squared, they said questioningly. Yes, of course it is 5x squared. Alrighty. All of that is grade 9. Do not make me get out algebra tiles, because I hate them. You will see them soon, because I am forced to show them to you. Then I am forced to take my pen and pretend to stab it into my eye, because I despise algebra tiles. But everyone remembers like terms now? Okay, the silence will end here when I ask a grade 8 question. Thank you. All right. So, if it is very similar to adding and subtracting variables, what do you think happens if I ask you to do this? 3 square root 2 plus 3 square root 3. Do you think you can do that? How many people think you cannot do that? One hand. I'm going to say this slower. Adding and subtracting radicals is very similar to adding and subtracting variables. Now I'm going to highlight two more things. Then I'm going to highlight two more things. Then I'm going to highlight two more things. Are the things highlighted in green the same thing mathematically speaking? Yes. What do we call them? It starts with a C. Excellent. I didn't even have to get to the T and has coefficient in the middle. Good job. But I'm still doing the joke. Okay. What does a coefficient do to the thing after it? What is a coefficient doing to the thing to which it is attached? Multiplies. Excellent. Okay. So if everything in green is the same, that's your first thing. Evidence in your brain. Okay. All the green things are coefficients. They all do the same thing. Therefore, they're the same. Got it. Okay. Next thing that's highlighted, very similar to adding and subtracting variables. Yes? Okay. Could I do this? No. Why? Because they're different. So, can I do this? No. Why? Because they're different. Good job, Nicole. This is, of course, not possible. Why? Why? They're different, aren't they? The square root of 2 is not the square root of 3. So you cannot put them together because they are not like terms. Can I do this? Why? Because they're the same thing, aren't they? Root 2 is root 2, yes? How many root 2's do I have here? Well, here I have 3. And how many root 2's do I have here? Another 3. To make 6 root 2's. Math. Wow. If only it were the same every single time. No, wait, it is. It's done. Yes. To add or subtract radicals, the radicands must be the same. Just like variables. Because all x's in the question are the same. So they can all be put together. All root 2's in this question are the same. Do we actually know the value of root 2? No, because it's irrational. But we do know that it is 1.414 blah, 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 blah forever. And we know that this means there's 3 of those. Then I'm going to add 3 root 3's, which is 1.73, blah, 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 blah. Not the same, is it? But this is the same. Everybody good? All right. So look at this very first one, which I have nicely used 2's and 3's. Can you do that? No. Why? Because the radicands... Oh, wait, we can do that. I'm getting to it. Some of you said no at first. What made you say no? Pardon me, Emma? There's a coefficient there. Yeah. And there's none there, but there is, isn't there? What is it really? Technically, it's a 1. So, I got 1 root 3 and 2 root 3's. So, can I add them? To get how many root 3's? 3 root 3's. Remember, what's the only thing that matters when you're adding? The radicand, which is that guy under there. You can, Bavneet. Now, so let's look at B. B is the one that everybody should be able to do right now in approximately 0.25 of a second. What is it? 8 root 6. Yes! Well done there, ladies and gentlemen. Now, C. Bum, bum, bum. Now remember, it's exactly the same as variables. So this is what you think. 5x minus 3x minus 4x plus y. That's what you think. So what do? What? Of course. So you do 5 and you take away 3, which is what? 2. Then you do what? Take away 4 more to get what? Negative 2. But it's not x's. What is it? Root 7's. Plus what? It's not y, it's root 2. Everybody good? Okay. What do you think is going to happen with D? So what is D? What are you going to do with the blue? You're going to do the root 6's first because they have the same radicand, yes? How many root 6's are here? This will not fool anybody anymore. 1. How many are we removing here? 2, for a total of what? Negative 1 root 6. Do we ever write the 1? No. Negative root 6. Now, can we do anything here? Can we do anything here with the 6's? No. Why? Because it's not the same radicand. But can I do anything here with the 3's? What would I do? You would subtract. How many root 3's do I have here? I have 1. How many am I removing? 3, for a total of negative 2 root 3. Because the radicand doesn't change, just like the x doesn't change when we are adding and subtracting. Is everybody Gouda? I just put some Gouda in my scalloped potatoes last night. I had a little bit of Gouda left over, so I grated it and threw it in with all the leftover cheese in my fridge. There's a little Parmesan in there, a little Swiss, a little Gouda, a little one that had a bunch of mold on the outside that I cut it all off and then grated up the little bit in the middle of it because I'm cheap. It was delicious! And I cut up some of the Easter ham and threw it in there too. Oh, so yummy. So yummy. If you don't like ham or you don't eat pork products, imagine how yummy it would be without that. Because it was still scalloped potatoes. And everybody loves scalloped potatoes. Who doesn't love scalloped potatoes? Any of you not like scalloped potatoes? You don't like scalloped potatoes? What's wrong with you, man? What is it? Is it the creaminess? Yeah? You know what, Duncan? I'm not going to lie to you. I didn't like scalloped potatoes when I was your age either. There's something I've grown into. True story. I did not like them when I was a kid. I was like, those are disgusting. But when you get a little older and you got to buy your own food and you realize you can buy 10 pounds of potatoes for the cost of one steak, you start to learn to like all the things you can do with potatoes. Because potatoes are cheap like borscht. I don't know why people say borscht is cheap. And you go to a restaurant, you order borscht, it's expensive. All right. Everyone is good? Okay. Now, you guys are smart kids. Math has piled on top of math since the first grade, hasn't it? It doesn't stop. Let's pile some math on top of other math. Can you do this right now? Yes or no? Not as is. Why? Because they're different radicands. But you remember 4 days ago what to do with a radicand that is big. What do? Simplify it. Excuse me. Many of you could factor tree that. As a matter of fact, every one of you could factor tree that. I'm hoping that you are all by now seeing the shortcut to that and recognizing that 32 is 16 times 2. Why did I choose 16? Because it's got a perfect square. What is it? 4. So what comes out? 4. And what stayed under there? Root 2. Nicely done, grade 10s. What's 8? Well, I would say 4 times 2. Why? Because then I can take out the 2. Yeah? So what's coming out? 2. And what stayed under there? 2. Giving me what? 6 root 2. Bum, bum, bum. I know. It's all right. You can't all be as energetic as the 43-year-old at the front of the room. Can't possibly be. No. Not you young guys that are full of life, right? No, not you. Us old long in the tooth over the hill guys. Can't be that energetic. No way. What? Can we do anything here? Not right now. We can do no adding nor subtracting, can we, Tavleen? But what can we do, Tavleen? Simplify. What's 28? 4 times 7. That looks like the next one. What's 63? 9 times 7. What's 112? 16 times 7. She is dead serious. She would not risk messing about with radicals. What is the square root of 4? 2. So what comes out? What stayed under there? 7. What's the square root of 9? So what comes out? What stayed under there? 7. What's the square root of 16? 4. So what comes out? 4. What stayed under there? 7. What's 2 minus 3? What's negative 1 plus 4? 3. Root 7. Holy Toledo. Just stop right here for a moment. Let it sink in for a sec. Let's take a Zen moment right here. Namaste. I heard a very interesting interview on the radio yesterday. How many of you feel, now you shouldn't feel this way, but how many of you feel when you go on your various social media feeds, whatever you choose to use, MySpace or whatever, and you see other people living what they like to tell you is their best life? Have you seen this? What do you think entails living your best life? Tavleen?
Honestly, like when I see that stuff online, I really think it's bullshit because if you're gonna have to convince other people you're living your perfect life.
I couldn't agree with you more. I could not agree with you more. When I see that stuff, because of course I don't look at that stuff because I usually imagine how good my elbow would look smashing into their faces as they do their downward facing dog in the sun drinking their kale smoothie. According to those people, to live your best life, you need to get up before the sunrise. You get bonus points if you see the sunrise. You get triple bonus points if you're doing some kind of exercise while the sun is rising. And you get quadruple bonus points if you are carrying some sort of disgusting smoothie that you try to say is good, but really tastes like horse feces, because that's all that's in it is wheatgrass juice. So you can live an extra millisecond when you're 97. Then you don't go to your job, because if you're going to your job, you're wasting your best life. So you go work for some miracle company that is saving the world and donating every spare penny of their profits back to saving the world. And then you take a 3-hour-long lunch in which you have time to work out, get that smoothie, and grab a shower. Then you get home to your perfect children who have done all their homework, cleaned the house, done all their chores, and then your perfect husband gets home from his exact job, or perfect wife, from his day of doing the exact same thing you just did, all of this by 3 o'clock, and then you have unlimited funds to vacation all the time to various yoga retreats and do the exact same thing again. Of course that's how life works. And if you aren't living that life, are you living your best life? No. And what does that make you feel like? I should be living that life. No, you shouldn't. Exactly. You should be imagining exactly how much self-defense courses you need to beat those people up. Because that's not the way the world works. And you shouldn't feel bad that you don't do yoga all day. By the same token, if you do yoga all day, he said do. If you do yoga all day, that's okay too. But don't tell everybody else that they're not living their best life because they are not. Namaste. Okay? Okay. Are we back, Shotzi? Have we had enough for this to soak in? Okay. And do you know what was funny about all this? The person giving the interview was a life counselor who says, I spend all day at a job I love telling people to ignore other people, telling them how to live their lives. Yet I go home and I feel bad when I see all these other people on my social media telling me how to live my life. I thought that was supremely ironic. Do we need to do a lesson on irony, or are we all okay with that? Okay. How's your irony there, Max? Awesome. Ironic. Hey, wait a minute. That looks really familiar. We just did that one. How did that happen? I bet you guys could handle that. Go. I'm just kidding. We just did that one. We'll do this one now, though. Uh-oh. Things are different. Oh, all right. What's 28? 4, 7. What's 63? 9, 7. What's 112? 16, 7. What comes out? 2. What's already there? So what do we have? 10 root 7. What comes out? 3. What's already there? So what do we got? 9 root 7. What comes out? 4. What's already there? So what do we got? 8 root 7. What's 10 minus 9? What's 1 plus 8? 9 root 7. Gouda? Okay, now, holy crap. This is where some people, and I won't mention any names, but somebody's already gotten mad about it today. What's happening here? What makes this look like something that you should be scared of? The variables. Need you be scared of the variables? No. Because of this. This expression, root 28, is really what? What would you do with root 28? You would, what? Break it down to what? 2 root 7, yeah? Because this is 4 times 7, yeah? Root 28 is 4 times 7, and it is 2 root 7, yes? Okay. What is 4c really? Look at the pattern. Look at the steps I took here. What is this really? It's 4 times c, yes? What's the square root of 4? So what comes out? What stayed under there? C. Okay. What's this really? No, just this part. Just this radicand. It's 9 times c. 9 has a perfect square, so what comes out? 3. What's already out? So what do we got? 12. What do we leave under there? C. What's 2 minus 12? Negative 10 root C. So, does this, which looks totally different from this, follow any of a different path? No. Even though it looks totally different. Does everybody understand? If I told you C equaled 7, then I would have had root 28, wouldn't I? And then you would know what to do, right? Well, everybody cool? Everybody good? So if I gave you this, 32x squared y plus root 8 y. Could you do that? What would you do with that? Go ahead. Well, I would use 16 and 2. Yep.
So you pull up 4.
Yes.
4 into x, you got x squared.
Uh-huh.
And then you need 2y here.
Excellent. What's happening over here?
And then that's 4 times 2, so you pull up 2.
Mm-hmm.
And you do y.
Just the y?
And 2 and y.
2y. Excellent. Then what?
You can add them together.
Can you, though? Remember, all math works. What would you do if there was no radicals here? What would you write for just what's highlighted? How would you write one expression that has those two highlighted terms in it? You got it. 4x plus 2. You got to go back to grade 9. That's 4x plus 2, yes? Times what? Root 2y. Is everybody good? That's about as hard as we can get with addition. But please notice, it's just everything you already know piled on top of each other. Yes? All right. So, let's have a look at this crazy question and see what we can do with it. I need to find, this question is a lovely question because this question requires you to know everything we have done in the 10th grade so far. Right? It does, doesn't it? What are we going to do with that? What do you see there that is something you know how to work with? Pardon? You see some right triangles, so trig might be involved. There might be some SOHCAHTOA. What else? What else deals with right triangles? Pythagoras. And Pythagoras deals with square roots, yes? So if I can put all that together, I'll be in business, right? So I need to find x. There's that part of x. And there's that part of x, yeah? If I can find those two and add them together, am I in business? Great, go. Is there a right way to do it, a right order to do this in? No. So what do you think we should do there? I'll wait a few moments and I'll ask for anyone to volunteer their first step. Well, not a few minutes. I'll wait another 45 seconds. Because almost everybody should have done a similar first step. Okay, would anybody like to share just their first step? Karina. You used, I'm sorry? Tan, yes? So you used tan for the blue line. Did anybody do something different than tan? What did you do, Lula? Lulu, sorry. Yeah, you remembered that special triangle thing, which is helpful too, right? But you didn't need to. That's cool. But even if you remember it's a special triangle, you still probably needed to do, we'll come back to that. So, Karina went tan 30 equaled 40 over that, yes? Which I assume you gave another variable to. You didn't make it x. A, right? Right? Opposite over adjacent? Yeah? Yeah? Okay. And did somebody over here, some people over here probably did tan 30 equaled 30 over b. I bet some people did that, yeah? And then you went through and did your work. Agreed? Okay. Now, what Lulu did for her first step was she said, that's a special triangle, yeah? Which means this is 2, 1, and root 3, correct? Except this is not 1, this is 40, right? So what did I do to 1 to get it to 40? Multiplied it by 40. So what's this? 80. And what's this? 40 root 3. Cool? What's this? Same special triangle? So what's this? 30 root 3, yeah? What's 40 root 3s and 30 root 3s? 70 root 3. Now, is anyone in trouble for doing tan all the way along? Of course not. Did you get the right answer? If you did tan all the way along, you ended up with tan 30 equaled 40 over A, yes? So A equaled 40 divided by tan 30. Cool? And B was 30 divided by tan 30, correct? You did that with your calculator, you got an answer, yes? What answer did you get? Pardon me? A big decimal, yes? Yeah, I agree. Look at the question. What does the question say? Are decimals exact? No. So, I ask again, why did I put that in big old highlighted, well, capital letters? 70 root 3 is exact. Is everybody cool with that? Okay? I need you guys to be aware of the difference between exact and approximate. Okay? I'm going to put something in the middle here, root 8. Exactly 2 root 2. Approximately root 8. 2.828427125. Is everybody cool with the difference? Is one more right or wrong than the other? No, of course not. Which one do we use in the real world? The approximate one, of course we do, don't we? We would never build a house and say, that roof needs to be 2 root 2s long. Would we? No. We would say that roof's got to be 2.83. Understand? Everybody cool with that? One is math class, one is real life. Okay? Everybody good? All right. Now, I'm going to do something that I don't normally do. I'm going to do a little bit more work because it applies perfectly to what we just did. It folds in to the next thing really well. Okay? Is multiplying related to adding? Yes or no? Yeah, because multiplying is just adding on top of each other, right? We wouldn't go 2 plus 2 plus 2 plus 2, would we? What would we write? 2 times 4, right? Because there's 4 2's there. Cool? All right, so multiplying radicals, since it's related, multiplying radicals can only occur if the radicals have the same, what do you think? Something's got to be the same. Radicand again. Why? Because it's exactly the same thing as we just talked about, yes? What is x times y? Do you know? It's xy, isn't it? What is x times x? X squared. Because they're the same. Okay? They got to have the same radicand. So, in here, Do they have the same radicand? Yes or no? No. So, if it was variables, it would be xy, wouldn't it? All right. So, what do you think we do with the coefficients? What would we do if this was 3x and 2y? What would the answer be? 6xy. So what do you think this answer has to be? Negative 21. Now, x times y. Oh, sorry, negative 35. Sorry, guys. I was doing 7 and 3. Just waking up. I'm old. Oh, wait a second. Okay, now, what did we do with x and y? We multiplied them together, yeah? And we just left it as xy, right? You guys are smart kids. This is not x and y. This is 3 and 8. So what will we do you think? Multiply them together. What is that? 24. 3 times 8, which is negative 35 root 24. Okay? Same radicand, you dumbass. Same index. Oh! Oh! Stupid! Stupid! You're so stupid! What would you do with 24? How, Stanley? Yes, that is 4 times 6. What is the square root of 4? What comes out? What's already out there? Negative 35. And what do I do with those two numbers? Multiply them to get what? What kind of 70, Stanley? Negative 70. And what did I leave under the radical, class? 6. All right? Excellent. Now, let's have a look at B. Can I multiply them together? Yes or no? Yes, why, Max? Because there's a hidden, not a 1.
It's not a 1.
What's the hidden little index? It's a 2. Because index is what's important, not radicand. Because I'm so stupid. So, there is also a hidden 1. What do I do with the coefficients? Multiply them. What is 3 times 1? 3. So I do 3 times 1 outside. And then what do I do inside? What did I do here? So what do I do here? 2 times 8. Yes? So this is 3 root 16, correct? What is the square root of 16? So what comes out? 4. What's already out there? So what is this answer? 12. Is everybody good? All right. Let's have a look at C. Can I multiply C? Why? Because they have the same index. So, what do I do with 8 and 6? Multiply to get negative 48. And what do I do with 6 and 12? Multiply to get 72. Would I leave it like that? No, of course not, because 72 is 36 times 2, yes? What's the square root of 36?
6.
So what comes out? 6. And then I would multiply here, yes? Which is? What's 6 times 40? What's 6 times 4? 288 is the answer. Negative 288. And what did I leave under there? 2. Now I want you guys to do something to remind yourself of that question, because we're going to come back to that in a sec. What's different on D? Are they different index, Bavdi? No. Does anything change? That's okay. Does anything change? No, but I'm going to give you a gift here. This is 3 times 1, which is 3, root 9, yes? What's the square root of 9? 3, so what comes out? And what's 3 times 3? I'm going to give you a gift here, which you've already seen before. Root x times root x equals what? X. So root 3 times root 3 equals what? 3. So it's 3 times 3. What is root 172.5 times root 172.5? 172.5. Little present for you. When you square a root, you get the radicand. All right. Now we're going to start to get a little funke. Look at E. Everyone's looking at it. Think about what you already know, which is how to multiply over brackets with variables. That's what you already know. And apply what you already know to this scenario. What do you think is going to happen? So what is this first term going to be? What is this first term going to be? $15 root 16. Excellent. What do you think the second term is going to be? Root 24. Excellent. And the third term? Minus 5 root 40. Is there anybody that cannot see how I got those 3 numbers? 8 times 5, just like we did 8 times 3 and 8 times 2. Everybody cool? Now, would we leave it like that? No. What is the square root of 16? 4. So what comes out? 4. That equals 60. What is 24? Yes, because that is 4 times 6. What comes out? 2. There's already a 10 there, so that's 20 root 6. What's this? That's 4 times 10. Out comes a 2. So it's negative 10 root 10. Can I do anything there now? No. Why? Because now it's not the same radicand, and I'm not so stupid because it is radicands when you're adding. Everybody good? All right. Now, F, can I multiply them? Yes, because they share the same radicand. Up until now, index. Up until now, what have we been doing with our radicands? We've been multiplying them together. Why is that a bad idea here, Max? You want to tag shots in? Shotzi. It's going to be a huge number. It's going to be the cube root of 864. Who wants to factor tree that? None of you. You guys are no fun. You're right. You would never factor tree that. So what do you think you do? Simplify now. What is this? Look closer. It's 8 times 2, yes? Why did I choose 8? Because 2 cubed is 8. So what's coming out of here? 2. What left? What stayed under there? 2. What's this? $27 times 2. Why did I choose 27? Because what's the cube root of 27? 3 cube root 2, yes? Now, does that look a lot easier? What's 2 times 3? 6. Cube root. What do I do with the radicans? 4. Now, somebody here says, but Mr. Mars, you just said that if I squared them, I get the radicand. Is this squaring? No, this is cube root, yes? So it has to be cube root 4. Right? Everybody cool? So what am I going to do with G? Do I want to multiply that first? I can, but that would be silly, wouldn't it? Because then I got to factor 1,000. I can't even be bothered. Why would I ever do that? When this is 4 times 7. And this is what? 9 times 7. What do I do with that 4? Bring it out and get 2. So I get 10 root 7, yes? What do I do with this 9? Bring out the 3, and there's already a 3 there, so it's 9 root 7, yes? What's 10 times 9? 90. What's root 7 times root 7? 7. What's 90 times 7? 630. Okay. Trouble. Some of you may not ever have seen this. Some of you, your 9th grade teachers, may not have shown you this. Is there anybody that has not seen this? Some of you won't have seen it. It's okay. You need to be honest with me. Okay. Have I ever given you something that you cannot do? No, I haven't. You have all the tools you need to solve this. Okay? Let's pretend. Pretend with me. Is everybody pretending? Pretend that it's that. What would you do? What would you do with this 2 root 8? You would put it there and there, yes? Yes, you do FOIL. See, some people still haven't heard of FOIL. That's why I'm doing this. Okay? You would do this, correct? And you would get 4 root 24 minus 6 root 16, correct? Everyone agree? Yeah? Okay. Now pretend that this side's not there. And what would you get? 6 root 21 and minus 9 root 14, correct? Then what would you do? Because I got 4 root 24 minus 6 root 16 plus 6 root 21 minus 9 root 14. Right? Then what would you do? It's just like what we've already done. Can you simplify any of that? You would simplify it all and find the right answer, yes? Okay. So, that's what you would do if nothing was there. So here's what you're going to do now. If you haven't seen this before, you do what is called FOIL, which stands for first, outside, inside, last. Do the first two. Do the outside two. Do the inside two. Then do the last two. And then you just collect all your like terms. Is there anybody that has never seen that? There's a couple of you that won't have. And that's okay, right? But you know how to do it. It makes sense. It's exactly the same as doing this. 3x plus 4 and x plus 4. You would do that, and then put them together, right? That's all you're doing. It's just distributing twice. Everybody cool? All right, now I'm going to do something a little weird here. Your next page should say dividing radicals. We are not touching that. Division of radicals is a whole big mess. We're going to take a whole day on that. All right? Your next page should be, no, keep going till it's not dividing radicals. Stop there. It should say Pre-Diploma Math 10 Radical Assignment. Yes? Yes? Okay. On that page, which I do not have in my book, of course, on that page, you need to do all of page 116 and 117. Everybody cool? That's the first step. Turn the page over. 1, 2, and 4 on page 118. Just that. Just 1, 2, and 4. Not 1 to 4. 1, comma, 2, comma, 4. I know there's no 3 there. So it is technically 1 to 4. All right? It's also 1, 2, 4. But it's also 1, 2, 4. Everybody good? Now listen to me. Everybody listen, please. This stuff is really essential to the 11th grade. Okay? Really essential. Being able to work with radicals is really important. All right? So I need you guys to actually do some of this tonight. Okay? You have to do it. All right? And I want you to all go back and have a look at that surface area thing, because there is no reason that you guys couldn't do that. All right? Now, tomorrow, depending on how well you do with adding and multiplying, division can go like that, or it can take a little longer. It just depends. You guys have been pretty good with new concepts because you're pretty good with your old concepts. So we may get through division really quickly tomorrow. We may not. All right? So what I'm going to do is I don't want to come back. I want to go over the division notes tomorrow, assign you that division thing, and then up to page 119, I want to see done by Wednesday. Understand? Everybody with me? Okay. Whatever the second assignment was, it went up to page 119, didn't it? Yeah. Oh, crap. I thought today was Monday. Thursday. Yeah. By Thursday up to 119. Okay? So tomorrow, we'll go over division. Is something else happening Thursday?
Finish 119 or up 119?
Finish 119. Because tomorrow we're going to do division.
119 answers?
Yes, I know 119 has answers.
Oh. So then it's like all throughout.
Yeah. Up to that page in your book needs to be filled in. If it's not something that needs to be filled in, then you don't fill it in. Everybody good? Okay?
Also, tomorrow we're going to go over that surface area question.
Yes. What I do not want you doing, is attempting to go further on division, because it's not what you think. Okay? It's not what you think. Division of radicals is totally different. What you already know applies to the very first little bit of division. After that, it's totally new. It is completely alien to you, so don't try it. Do you understand? I know some of you will want to go ahead. I know that. You'll say, oh, this seems to make sense. Don't. Please, don't Google it. Don't go on. Just stop at multiplying. Okay? Because division gets weird. Not difficult, but weird. Okay? Okay.